Hello to all of you, dear friends. Welcome to the fifth and final session of our mini course. I hope you've enjoyed it so far. Well, in this session, since it's the last one, I want us to have a more comprehensive lesson. That means we'll be working with more components, and we'll also get more involved with the C language, just so we can once again showcase the capabilities of the microcontroller. What's our goal for this session? I want us to have a microcontroller. 2 buttons are connected to it. 2 LEDs and an LCD are also connected to it, and we want to detect when these buttons are pressed, display on the LCD which button has been pressed, and at the same time turn on the LED corresponding to that button. Even though this might seem a bit unusual, and often with circuit design alone, we might not be able to achieve something like this. It might require a really complicated circuit, but as usual, with the microcontroller, we're going to do all of this with just a few lines of code. Alright, as always, I'll start with the simulator. The components we repeatedly use include our microcontroller itself. Alongside that, there's the button. There are also light-emitting diodes. For example, we will be utilizing a vibrant green and a distinct red LED. And there's the LCD. LCDs, or generally displays. Later on, when we get into microcontrollers more professionally, you'll see that displays come in various types. That means we have everything from the simplest displays like 7-segment displays to character LCDs, graphic LCDs, color LCDs, OLED LCDs, and many complex displays like dot matrix displays. Dot matrix displays are like the scrolling signs you see above shop entrances. An array of LEDs placed next to each other is called a dot matrix. And these are the different types of displays. But one of the most basic, cheapest, simplest, and at the same time most industrial and widely used displays is the character LCD, which you might see in many industrial devices, or even, for example, in shop scales. Many of them use character LCDs or graphic LCDs, and overall, it's an industrial type display. At the same time, it's very economical and widely used. In Proteus, if we search for these LCDs by the name LM0, it will show us different types, and as you can see, I'm going through them one by one. They come in different sizes, but in the market, if you search, you'll routinely find 2 very popular sizes available. One is 16 by 2 and the other is 20 by 4. What does that mean? It means that the second number tells us the number of lines. So this one has 4 lines, and this one has 2 lines. As you can see, the height of the LCD also changes, and the first number tells us the number of columns. Now, the number of columns is actually the number of characters that can be displayed on each line. For example, what does that mean? Since the 16 by 2 is very commonly used, I'll add this one as a component in Proteus first. We're going to use this one. But now, if I want to give you an example, for instance, if I want to write salam, how many characters is that? That's 5 characters, and the 16 by 2 LCD says, I have 2 lines, and on each line you can display 16 characters. Another point is that these LCDs only support English letters, numbers, and a few special symbols. And if you want to display Persian text, that falls under the topic of graphic LCDs and generally more advanced discussions. But for displaying English text, these character LCDs are actually one of the best options. Alright, so we're going to place our microcontroller here in the middle and start by connecting the LCD. If we want to keep the video length under control and not make things too complicated, I'll give a brief explanation about the LCD. In the practical world, although of course we've already agreed that for now we won't get into the practical side, because we have plans for you and there are a lot of things we're going to do together. But anyway, in the practical world, we just have a couple of extra power pins and we don't really deal with them. Apart from our essential power pins, which prominently include the LCD backlight and its own dedicated power supply and so on, we also have a comprehensive set of crucial data pins located here. For the moment, It doesn't really matter precisely why they're named the specific way they are. It's simply very good to begin to get thoroughly familiar with them and their functions. Because in the software, we assign the pins using these names, and the standard way these data pins are connected in CodeVision is that it uses these 3 and the last 4 pins. And this LCD actually supports 8-bit mode as well. But to save on pins and connections, and so that not too many of the microcontroller's pins are used. Because in large projects this is very important, we use the 4-bit mode. That means we only connect the last 4 pins and these 3 pins to the microcontroller, and this connection is completely up to us. It's just that since CodeVision has a nice order, I'll connect them for you in that same order. For example, if I want to use port A, CodeVision tells me, hey, RS should be on your first pin, RW on the second pin, E on the third pin, then leave 1 pin empty. Then connect D4 and D5 up to D7. As I said before, this connection isn't important at all and can be completely changed in the code. Now let's take a look at it together. Alright, next I have the buttons. For example, I will connect 2 distinct push buttons to port B of the microcontroller. And, as you are already well aware, one particular side of these buttons should always be connected to the common ground reference so that we can effectively pull up the other corresponding side on the microcontroller's input pin. What exactly is a pull-up resistor and how does it function in this circuit? Why is it done? These are topics we discussed in the previous session. And on the other side, for example, I connect the LEDs to port D, 1 green, 1 red. And the other side of the LEDs is connected to the circuit ground. Now this circuit looks a lot more cluttered. It might even seem like it has much weirder code, but no, that's really not the case at all, and now we'll look at the code together. So keep this in mind as we move on to CodeVision. In CodeVision, I'll start the project from scratch again, creating it. By now, this process should really be ingrained for you, and you should be able to create a project with your eyes closed. In the microcontroller selection section, we have the ATmega32 again. Let's move on to our port section. For the LCD, we don't need to do anything extra. Now, as you'll see, we just want to set up our buttons and LEDs. So, what should pins 0 and 1 of our D port be set to? Output, because they're connected to the LEDs. Port B, pins 0 and 1 should be set as output. Pins 0 and 1 of our B port should be set as input with pull-up. Why? Because it's connected to the button. So we set up port B. Pins 0 and 1 should be set as input with pull-up. Now for setting up the LCD is one of those components that's generally quite hard to control directly. Of course, when I say quite hard, I mean for someone who's currently learning. Of course, later on, someone might want to write their own library for the LCD and could do it quickly and easily. But at first, this is generally difficult because you need to fully understand the LCD, figure out which commands need to be sent, which pin should be set to 0, which pin should be set to 1, and what happens as a result. But it's one of those cases where CodeVision has provided a very complete and simple library for it, and we use that library to handle all our tasks. The only difficult part might be setting up the connections, that is, specifying how the LCD is connected in the code, but thanks to CodeWizard, this is fully taken care of for us. In CodeWizard, we have a section called Alphanumeric LCD, or Character LCD, which we activate. It has a controller, and all the LCD controllers available on the market are of this same type, so there's no need to change it. And here, it only asks us for the number of columns. The number of rows doesn't matter to it. In our case, the LCD has 16 columns. And that's why I told you earlier that it's not important to know which pins are which. Because right here, it gives us the full names and asks us to specify which one is connected to which port and which pin of the port. That means these can be connected in any combination to all the microcontroller's ports. But as you can see here, RS, RW, and E are connected to pins 0, 1, and 2 of port A, and D4 to D7 are connected to pins 4 to 7 of port A. It's a neat connection that CodeVision itself has set up, and we're going to use it as is. But as I said, changing it won't cause any problems or disruptions in the program. So up to this point, we have this set up and we're creating our code. Again, as always, it's our usual repetitive process. Alright, our code has been created. We can see that it has automatically imported a new library for us. The LCD library, which stands for alphanumeric LCD, and it says that the alphanumeric LCD functions are included in this library. One thing you need to know is that a lot of these things can be easily found with very simple searches. Even the official CodeVision resources and such have tutorials for these, and often you can find many commands right in CodeVision's own help section. For example, if I type LCD here, logically, yes, as you can clearly see, it's effectively showing me some of its various functions, and you can certainly utilize these as well. You can meticulously observe and determine which specific functions are comprehensively included in each particular library and precisely which ones they inherently possess. So in this way, I now have the LCD library ready. I have my inputs and outputs ready, and here as well, it gives me an explanation in the form of a comment saying that if you don't remember, you connected the LCD like this. Its pins are connected to this port and these pins. It's a 16 size and it has itself initialized the LCD for me using the LCD init function and the size 16. Now, all we need to do is just put our own code in. So how do we want our code to be? Now, to make it a bit more interesting, let's assume these buttons are for turning the device on and off. For example, this first button is supposed to turn our device on. The second button is supposed to turn it off. When the device is turned on, for example, the green LED lights up. When it's off, the red LED lights up, and for instance, it's connected to a relay that switches on, so let's assume something gets powered on. At the same time, the LCD should also display whether our device is on or off. This is a very simple project, but it can actually be really useful in many situations. Alright, let's go ahead and write the code. This is the simplest code you can write using C language conditionals. If I want to make it more advanced, I would have to introduce other C language commands, but that's not the goal of this tutorial right now. I just want to add a couple of very simple conditions. Again, just like in the previous lesson, we said which register we're going to use for input, right? Pin. I'm saying that if pin be 0, meaning the first button becomes 0, that means the button has been pressed. It should perform a series of actions for me. And I'll also make a copy of this. If pin B.1 is pressed, that means the second button has been pressed. Let's do a few things. Well, the first thing I wanted to do, which is also a repetitive task, as we saw in the previous code, is turning the LEDs on and off. So our green LED was connected to pin 0 of port D. So I say set port D.0 to 1 and set port D.1 to 0. The point is, just like controlling a 7-segment display and such, we can do this entirely with a single portd command. That is, we can say portd equals 0b001. This way all of them are off and only the first one is on. This automatically turns on the first LED and turns off the second one. But for better readability, we'll use the first method. And we'll do exactly the opposite for our second button. That is, we want our green LED to be off, the red LED to be on, and we run our code. So what will the result look like? We haven't uploaded our code to the microcontroller yet. You see, up to this point, I haven't used my LCD at all. So if I press the first button, the green LED turns on. If I press the second button, the red LED does. Even just up to here, it's something very simple, interesting, and practical. Now, I want to add an LCD display to this as well. So for displaying on the LCD, we have a function called LCD clear, which clears our LCD. It doesn't matter whether something was already displayed on it or not. So we have an LCD clear, we run this function, and after that we have an LCD puts, which displays a string of characters for us. Naturally, this string should be up to 16 characters, and it shouldn't be longer than that. For example, since this is our primary power on key, we definitely want to display the message device air on. This message confirms the device's air system is operational. Now if we count the number of characters, it's 2, 4, 6, 8, 10, 12 characters. And for example, to center it on the LCD, I can add 2 spaces on each side. By itself it was 12 characters. With these 2 it becomes 14, and with these 2 it becomes 16. So this phrase will be exactly centered on the LCD. Now I'll copy this and use it for the second key as well. And for the second key, I just say that instead of off, show me on as off. And now my phrase shifts a bit to the left because it has 1 less space on this side. Now it might go to the right, but for example, I can move it to the left to make it look nicer. And in this way, what are we saying to do now? If we want to review the code flow together, we say that if the first key is pressed, it turns on the green LED, turns off the red LED, clears the LCD, and displays this phrase on it. If the second key is pressed, it does the opposite. It turns off the green LED, turns on the red LED, clears the LCD again, and displays this phrase on it. Now I will compile this, and if we then run it, by simply pressing the very first key, it clearly tells me that the device is indeed on. Our electronic device is powered on and fully operational. The green LED turns on, and if I press the second key, it says device is off. The red LED turns on, and this process can repeat infinitely. Now you can see how simple it is. Really, it's very simple. As you can see, I think we've written barely 10 lines of code here, and with just 10 lines, we're able to achieve such precise and interesting control over a modern device like an LCD with 2 LEDs and a button. And these are things that, from this point on, circuit design alone can no longer handle so easily. When I keep mentioning circuit design in my talks, what I mean is using ICs, resistors, capacitors, and other routine components of traditional circuits. In other words, anything other than microcontrollers and microcontrollers, because as we said in the first session, it's considered a computer, a small computer, so it can easily handle many of these tasks. Right now, this project has a lot of potential for expansion. I mean, even this simple project can provide you with plenty of exercises. For example, having a set of basic phrases, filling up 2 lines of the LCD, for example, displaying the device name. All of these features can be added, and they can all serve as practice exercises for you. And at this point, I can say that our mini course has come to an end, and I hope you enjoyed it. And once again, I repeat, as I mentioned in the first sessions, we have a main course planned for you, and in that course, we will also have hands-on activities. You will be provided with the necessary hardware, and we have many other programs planned together. And if after this mini course you've decided to enter the field of microcontrollers, let me tell you that you won't be left alone. We have lots of exciting plans together. For now, goodbye.